Okay, I'm back again now. Good question there from Kevin. Question is, if the ArrayList class implements iterator interface, why do we need to get the iterator? That is, why you need to type list.iterator. It's a good point. When we say the ArrayList implements the iterator, I should perhaps rather say that it exposes an iterator or makes one available. It doesn't actually implement the iterator interface. So when we say list.iterator, we're retrieving an iterator from the ArrayList, and then we're using it independently. That's kind of core to how the iterator pattern works. It separates out the iterator from the core data structure itself. We can discuss that more in the chat room at the end of this session, if you like. So we've been on a journey now from exploring inheritance, distinguishing between implementation interface inheritance. And then we've encountered our first real life example of that, perhaps in the collections framework, which is a range of interfaces and their implementations, and also some further implementation inheritance customizations of those classes, as in the linked and linked list implementations and others we will allude to briefly. Let's keep going with collections because we haven't got the full story yet. In particular, we need to talk about generic collections, the collection interface itself. We'll just have a quick look back at it to see if we missed anything. Some aspects around the features of collections and a peek at how you might reason with choosing a collection. And then lastly, just some observations on working with collections and some further references I'd like to discuss briefly. First of all, back to this examples that we had earlier, this number dictionary we had. And in this example, we are looking up the dictionary. Here, we're performing a get. The get is giving us back an object. That object is the value in the collection at the key 1. It is actually a string, so we're casting it then. And the cast operation is needed for us to actually recover the string itself. Otherwise, we just have an object that we retrieved. Now, this clearly isn't a very attractive way of programming. It was how collections worked for 10 years, a little more, 11, I think. But there was a substantial revision to collections made in about 2 releases ago of Java, and generic collections were introduced. And this allowed us to really have a closer look at the type system in Java and provide some amendments to that type system to improve its readability and reliability. And this came to be known as the transition from unsafe to safe, or from untyped to typed, particularly in collections, but the notion also applies to any other class that you would choose to build yourself. So once safe or typed collections were introduced, we had a significant reduction in the noise around using collections in terms of the syntactic signals we had to send. Simple enough idea, really. And again, you've already seen it. For declaring an array list, we specify in the array list the type we want the collection to manage. That's specified in angle brackets like this. And in between the angle brackets is a type name. And this can be any appropriate Java type. When we create an object that's an instance of a collection, we're then specifying the type itself here. The same type appears. This is called a parameter or a parameterized type. That allows us to drastically simplify accessing collections. If we go back here and look at some of the examples we had earlier, an array list, I can add things in the untyped unsafe or typed safe mode. And the key change here you'll notice is there's no cast required anymore here. When I call get, I'm getting back a string. This is relying on the generic features introduced into Java at this time. Same for iteration. If you looked carefully at the previous examples, there was typecasting required for the iterations to work correctly. Now it's no longer needed. Here I'm asking the list for its iterator. I'm using hasNext and next to guide me through the collection. And the next method in particular returns the appropriate object for me, a string object, which I'm printing out in this instance. So all of that is a big advance over what we had previously, and it's the standard way now we program collections. Particularly noticeable when we're using hash maps, because they can get very noisy, particularly all the typecasting. And the hash map as implemented now is easier to reason with. Here I'm declaring number dictionary, putting elements in, putting 1 in at position number 1, and then I'm retrieving the collection, the element here by key, without any casting required. For loop also introduced around this time, and the for loop works with iterators and then works with collections that the iterators are associated with. Sometimes called a for each loop, and there are variants of this now in most modern programming languages. So for the iterating through a list, we can dramatically simplify it. Here we have the version we encountered previously, which was using the iterator to extract a, if you like, a pointer or reference into the list, and then use that reference to guide us through a for loop and retrieve individual elements. Down here we have exactly the same operation using a for each loop. I just declare an element object, colon list, list being the array I want to iterate through, and this loop now will kick off for us. Every element will be visited, and I'm just printing it out. I don't need to explicitly retrieve the elements or automatically retrieved for me. Now it's important to note that this relies on and uses iterators, the for each loop. Unless your container supports iterators, the for each loop is not usable. It also means that the for each loop can be used in other contexts. You could write your own classes that expose iterators, and the for each loop would work with those. So it's a general purpose facility, not just bound to the collections framework. Let's look at the collection interface again, and another view. It's a little bit richer now than the previous one we had. We see we got sorted and navigable sets here. We also have a queue and a deck. Again, these are variants of important data structures you may have encountered in the past. And also you notice we've got maps that could be sorted or navigable. So the names here are suggesting perhaps greater utility for some of these instances of the collections that may suit particular problems you're tackling. The collection interface itself, we've already looked at it. It's up at the base class. Let's just take a look at the other stuff that's in there. Add all, clear, contains, hash code, empty, iterator. We've just been discussing iterator in some detail. It's the signature there for the iterator method. Remove all, retain all, size, to array. These two actually are interesting. Didn't discuss these already. We can ask a collection to turn itself into an array. And you notice the bottom one here is a typed array. So possible to see how we could write some very simple and elegant code to interchange or translate from one data structure to another. Also note that the add all method, the signature, looks a little bit different now from what we had previously. In modern Java, we have generics, And where we have generics, we are passing types or indicating types in somewhat more obscure ways than we've been doing to date. A lot of controversy in Java around this question mark symbol here and what exactly it means. Don't propose to go into it now, other than to indicate that its meaning is highly ambiguous, and it's a bit of a problem for the language currently. Okay, quick tour of some other features. Performance, I'll name check, just to give you some references really for further reading. I'm not going to plunge into any detail. Here is just a kind of a summary table of some of the collections we've encountered and others you might want to explore. We're indicating here whether list, set, or map, the core interfaces we've discussed already, whether they're ordered or not, whether they're sorted or can be sorted easily, and whether they allow duplicates. So you might review that in your own time. Here's an extract from some analysis done on collections, and these are performance times in milliseconds or nanoseconds, sorry, for various types of operations on collections, and it's comparing different implementations. By the way, it's including in this comparison collection implementations that are not in standard library. So there are other collection implementations out there that have different performance profiles. Now, the nature of these differences adheres to the structure of the data structure itself. For instance, contrasting linked list with a non-linked or a standard array list. They have different performance profiles depending on how you're using them, whether you're inserting in the middle or at the start or the end, whether you're inserting and removing or inserting only, or other types of profiles. And the collections then exhibit different performance characteristics based on that type of usage. It's not really something we'll be getting into, that is algorithmic analysis, so much in our module. We're sticking with vanilla implementations and we're not really doing any profiling. But these profiling tools that we're showing here do indicate predictable differences in the performance for different types of operations across these collections. If you are using Eclipse and you are perhaps not adhering closely to generic or typed collections, then you do get a range of prompts from Eclipse to encourage you to insert your types effectively. So the compiler these days now are encouraging and almost forcing you into using proper generic syntax, and they'll fix the syntax if you're a little bit tardy in implementing it correctly. Also, they've been tuning the way some of these work lately. In particular, in the earlier example, we had a hash map. You may have seen hash map string string with string string appearing twice in the declaration. Well, this has been cleaned up in version 8, I think, of the language. So here we're seeing it's possible for us to have a slightly more elegant version of the declaration with just a single occurrence of the hash map string string syntax. Sorry, I'll clarify. I'm talking really about how this here has simplified our life slightly. Now that's an example of a little bit of type inference. We mentioned this in the very opening talk. That is where the compiler intervenes and figures out that it knows what you're doing and not so much inserts the type for you, but assumes the type is there and doesn't cause any objections subsequently. So for instance, we have a choice here of whether we insert string comma string in here again or not. And in this example, we're choosing to not do it, and we're not going to get any warnings or complaints. When we're using collections, just as we looked at earlier on in the inheritance talk, we generally tend to type our collection instances to the base type if possible. So the products is an array list, but I'm choosing to select list as the type of the products instance. Similarly, a map in that instance, or a set. Now the reason we do that is fairly simple, really. It allows us a little bit more flexibility in our implementation. It means that depending on the performance profile of our application, perhaps depending on results we get from running a profiler and looking in real life at how our data structures are being used by user data, we may change the implementation from linked list to array list, or array list to linked list, for instance. If we have typed the instances to the base type, we can do this without penalty, without further compilation, without further syntax adjustments. It becomes immediate and painless. In other words, we can refactor along the inheritance chain for a given data structure easily and without it having a ripple effect throughout our code. We've been using this in the few labs we've done to date. We've generally been attempting to declare lists as opposed to array lists, even though array list has been the concrete type. The for each loop, we've seen that again. Just refreshing your memory on it. They rely on the iterator being available, but we get substantial reduction in code size. 2-3 statements reduced here in this instance, which is quite attractive. Okay, that's more or less it then for our review today. Back to the diagram we had in the last talk. These are the main ones we're interested in for the moment, really. We realize we've got iterator, collection, map, set, and list, and then the 3 implementations we're happy enough to run with. We are able to use generics now across all of these as opposed to the legacy implementation. And we also have a for each loop now, which makes the traversal significantly simpler. There are a full range of other data structures I haven't explored here yet. I'm just mentioning decks here, tree sets, linked hash sets, and so on. Some summaries to why you might select those. For our module, we're happy enough to stick with the vanilla ones, so it's fine for the moment that we stick with our core. It is worth mentioning that there's a whole other family of collections out here, which is a little bit unnerving when you encounter it first. That is, the collection library has been dramatically expanded to cope with multi-threaded applications. So for all of our base interfaces, set, list, and also queues we didn't mention, there are concurrent variants of these data structures. Now we won't be doing any concurrent development. And multi-threaded development like this that would use these collections is quite rare and very specialized. Even in concurrent applications you may be building, Spring or other web applications, generally concurrency is excluded from the remit of the programmer, and you're relying on other abstractions internally to shield you from multiple thread access. However, they're all there. They're quite well respected, very complex, and quite an engineering achievement. Just mention some references. The most referenced book on modern Java development is probably this one here. This is only ever went to a 2nd edition, and I think that was about 7 or 8 years ago. So it's due an upgrade, but the author doesn't show any signs of producing one yet anyway. The author is a very well-known figure in the Java world as the primary architect of the collections hierarchy we've just been discussing. He worked at Sun at the time, then at Oracle. He now works at Google, I think. He has moved on to other languages since. I think that's why the language itself, the Effective Java book, has not been updated. I mentioned the question mark we spotted earlier on there in the collection interface. He has famously indicated that he no longer understands what that question mark means now. And he was closely involved in the design of the generics feature and its realization when he was working at Sun. So it's a little bit worrying that there are some loose ends there, but we'll glide over that. These two books I think are really excellent. I think if you're becoming a Java specialist, there's nothing like a book, and the Good Parts book is really excellent and well worth reading. Nice thing about it is it's 150 pages, not 500 pages of stuff. So well worth a little investment if you're interested in getting on top of this field. You don't need it for this course, really. Jim Waldo, again, is another very well-known veteran in this field. He was a veteran of the C++ days and did a fine job on that book. If generics and collections are really interesting for you, we do have another text. It's a bit more substantial than this one. I haven't read it all, in fact. It's useful enough, worth perusing perhaps for reference purposes. But generics have become a little bit tainted now, so investing heavily in trying to understand them when they're a little bit broken is well, it's a little bit off-putting perhaps. I could recommend the Good Parts though, and the Good Parts series in general is well worth checking out from O'Reilly. They do the Good Parts on quite a range of languages and frameworks, largely because these languages and frameworks have changed over time and accrued a lot of cruft. Java, perhaps as much as any other language. So the Good Parts attempts to distill down the subset that's modern and useful, and gives you some indicators and pointers as to which parts of the language are best avoided. It's particularly good on indicating which parts of the JDK and framework classes are best avoided, because there is some quite dated approaches in there which have been carried around now for many years, and sometimes the wisdom gets a little bit lost as to what you should avoid and what you should take seriously. Okay, that's our finishes our session for today. Thanks for your attention. I'm going to hang around in the chat rooms until 7 or 20 minutes. Labs go live tomorrow in the chat rooms again from 3 to 5 IST hours time. So we'll be attending those labs and happy to help out if you're having any challenges there. Next week, Siobhan will be back, and we're moving beyond our review of Java now at this point, and we're moving into some core practices of agile development, specifically testing. But we will be dropping in on some Java features occasionally just to tune up our knowledge and keep an eye on some recent developments. Siobhan is looking forward to taking you through some Java 7 and 8 features, maybe even some Java 9 features, although they're not quite released yet. Thanks again for your attention. I'll be putting these recordings up as soon as I can, hopefully tomorrow at some point, and I'll be dropping in you next week as well. Thanks again, and see you soon.